In all of Chapter 5, we're learning about delta H, or enthalpy change. There are 4 different ways that we can find out the delta H of a reaction, the first of which is what we're going to do in this lesson, which is HESS'S law. So according to HESS'S law, the heat of a reaction may be determined algebraically by adding the delta H values for related reactions. So I'm going to take a look at this example here. I've got 2 different reactions that I know the delta H value for. So I'm going to call this reaction 1, and I'm going to call this reaction 2. Now, what HESS'S law states, if I combined these reactions together, and when I say combined or adding these reactions together, I'm going to take all of my reactants of both reaction 1 and reaction 2, and I'm going to make it into one line here. So N2 gas plus O2 gas. So that's from the reactants from the first reaction. And I'm going to take the reactants from the second reaction as well. Oops. NO gas plus O2 gas gives. And I'm going to do the same thing for the products. I'm going to take the products for both reactions and I'm going to put them all on the same line. Right, so I've algebraically, or I've added these 2 reactions together. Now I'm going to take a look and see if there's anything on the reactant side and the product side that are the same. If so, I can cancel them out. So 2NO gas exists both on the reactant side and the product side, so I'm going to cancel that out. What I'm going to have left over is my reaction, that is N2 gas plus O2 gas. Now, if I notice there's 2 O2s here, so I'm going to put a coefficient of 2, which gives 2NO2 gas, right? So I've added these 2 reactions together to get this third reaction, okay? And this is often what we call the target reaction. I'll get to that in a bit. So the whole idea of HESS'S law is that if I'm adding 2 reactions to get a third one, I can add up their delta H values to get the delta H of that third reaction, right? I know the delta H of reaction 1 and reaction 2. And I know that if I add those together, I get this third reaction. I can add up those delta H values to get the delta H of that third reaction as well. So this is the concept. This is the whole idea of HESS'S law. Let's take a look at how we would apply that in the questions that we see, right? Just to sort of recap, when added, these reference reactions must give the desired or target reaction, right? So this reaction has to result from these 2 in order for us to add up the delta H's together, right? If this is not possible, if somewhere you don't end up with this reaction, this doesn't follow, right? You can't just add up the delta H's together if that's not the case. So when you see an example, so this is an example that we're going to work on later on in our lesson. This particular example shows us what our questions will look like, right? So you're always going to be given a target reaction. This is the reaction that we need to find the delta H for, right? So I'm going to be given this target reaction, and I'm also going to be given a bunch of reference reactions. So 1, 2, and 3. And I know the delta H values for all of those reference reactions, and I have to find the delta H for this particular target reaction. Now the problem arises because it's not always as is, right? If I write out these reactions and I try to add them up, most likely than not, I'm not going to end up with this overall target reaction. What I'm going to need to do is I'm going to make some changes to these reference reactions so that it can add up to this target reaction. So let's take a look at how we would do that. We'll come back to this particular example after we've sort of learned what the changes we can make are. So when we're making these changes, we can make them to the reference reaction. So let's look at this example. I've got N2 plus O2 gives 2NO. I know the delta H value for this reaction. Now say I need my 2NO to be on the reactant side. So right now in this particular reaction, it's on the product side. If I want it on the reactant side, I'm going to have to flip this reaction. And when I flip this reaction, I'm also going to show that, I'm going to represent that in this delta H by flipping the sign. So right now it's positive. When I flip this reaction, the delta H of that reaction is a negative 181 kilojoules, right? So this particular reaction has a negative delta H value. This particular reaction has a positive delta H value. So that's our first change. If you're reversing a reaction, the delta H, the sign of that delta H will change. Now, the second change that you can make is if you are multiplying a coefficient, right? So say in my target reaction, I need 4NO, and the only reaction that I have has a coefficient of 2NO. What I'm going to need to do is multiply this by 2. All of these coefficients are going to be multiplied by 2. So this is going to be multiplied by 2. This is going to be multiplied by 2. This is going to be multiplied by 2. As well as my delta H value is also going to be multiplied by 2. So what I'm going to end up with is the delta H for this particular reaction. So those are the two changes that we would be making to these reference reactions. You don't have to do them for all of the reference reactions, but in some scenarios, you'll see when it would be appropriate, right? So if you need your product, if you need the product of a reference reactant to be on the reactant side, then you would have to flip it over. Or if you see that the coefficient is different, then you would have to multiply it, right? So depending on the circumstance, you could do none of these, one of these, or both of these. So just to sort of summarize, if a reaction must be reversed, the sign of that delta H must be changed, right? So if it's a negative, it goes to a positive. If it's a positive, it goes to a negative. And secondly, when you're adjusting molar ratios, if you're changing those coefficients, you're multiplying by a factor. That same factor has to be multiplied to that delta H value as well. So in other words, both of these points can be summarized by saying whatever you do to the reference equation, you have to do to its delta H value as well.